So this is from the practice final, homework 4.7. And it is similar to a homework question we did a while back, about a quarter of the way through the first module. So parents group is writing a grant to support after-school programs for their children, and they want to make a point that government funding for after-school program has decreased over the last decade, while the cost of offering the programs has increased. So we have two different things going on here. We have the government funding in the first row, and the second row we have the cost. So let's look at government funding first. And we're going to assume, we're looking at rates of change here, so just assume it's changing with a constant slope over time. And so we're just approximating that. So what we want to find here for government funding is the average change. And that rate of change is the idea of slope that we've played with quite a bit. And so for the rate of change, what we're going to look at again is it's always the thing we're looking at in the numerator that we're calculating, the government funding. And so in 2010, it was 1,800. In 2000, it was 3,000. So notice it dropped. And so the way we write that is, what is 1,800 minus 3,000? And you can see 1,800 minus 3,000 is going to be a negative, indicating the drop in funding. And then we want to know how many years this was over. So that would be 2010 minus 2000. And so we can do that subtraction, and we're going to get, I think, negative 1,200 for the numerator. 2010 minus 2000 is 10. The numerator is in dollars, and the denominator is in years. And so we're going to get a final number that's dollars per year. So it looks like it is negative $120 per year. Right? So if I wanted to write that out in a sentence, I could say government funding for after-school programs
has decreased by an average of $120 per child each year.
Nice, you got it nailed.
Believe me, I have everything written down.
So I was going to write that out, nice sentence for the media or my mom. I'm having trouble writing today. So it's decreased, right? The negative. I don't want to say negative. That's not like a common word we use in a context like this.
You wrote deceased.
Oops.
Died.
That's funny. That reminds me of like trouble with spell check, right? Sometimes it picks the wrong word if we mess it up too much. And I once had a student that was writing to me about some troubles and they needed more time. And they were trying to tell me about this divorce with their husband. And they accidentally wrote, "I devoured my husband." That was hysterical. Decreased by about $120 per year. And I also want to take into account the information in the table that's also per child. Per child. It's on average, right? Because I don't have the numbers in between.
Oh, I left that out.
So on average, and then I also want to state the years. So from 2000 to 2010. So that would be a pretty good sentence there, taking into account the information we were given and our calculation.
Oh, I wrote government funding has decreased by an average of...
Yeah, so you put average in a different spot, right? I remember hearing you say that. Yeah, so again, there's lots of ways to word this. This is just my way at the moment right now.
But I did leave out the from 2000 to 2010.
Yeah, and that's a good thing to put in there because later somebody might say, well, when was this, by the way?
Yeah,
Is this
I
like the
just added it.
90s and yeah, so just to be clear, we should indicate what time frame this is. And then we want to do a similar thing for the cost of offering after-school programs. So let's take a look at that now. Oops, that's a line. Let's use the line tool. That's better. And so cost of offering after-school programs. Huh, why is my pen not working now? Hello. There we go. And again, we want to look at the average rate of change there.
It's an increase.
Okay. Yes, definitely we can see an increase there in the cost. And so with the average rate of change, we usually take the newer number minus the older number, and that tells us whether things have gone up or gone down. And usually we can see it, but we want to know by how much. So 5,100, take away the earlier amount of 3,800. And over the years, 2010 to 2000. And again, when we make these, we want to make sure we have the date and values line up in there. So notice 2010 goes with the 5,100. So those things have to line up to get it right.
Oh, do you know what I did? I just put like, to get that increase by 130, I just put 1,300 divided by 10 years.
Well, yeah, that's going to be, and we could just look at that and see the 10. So I don't necessarily have to write that. I could just look at it and see, oh yeah, that's a change of 10. This one I'm writing down because it's not so obvious that that's 13,000 or 1,300, excuse me, over 10 years. And again, these are dollars in the top, these are years in the bottom. So when we clean it up, we get $130 per year.
Is this a good sentence? The cost of offering after-school programs has increased by an average of $130 per child each year from 2000 to 2010.
Yeah, that's perfect.
Okay.
Good job. And so then the sentence that describes what that means right there, exactly as you said. And in the homework problems, I just ask you to pick a sentence or fill in the blank in a sentence. On the test, you're going to have to write that out in your own words for me.
Right, and I'm glad you said the dates.
Yeah, definitely want to practice. And yeah, the dates are relevant there. They matter. And that's part of the writing principle for the course. We don't want people to have to look back somewhere else, try and figure out what the heck we're talking about.
Yeah, what years?
Yeah, yeah. And I always thought this is a class that all journalists should take to make sure they're getting this stuff right. And again, there's always slight variations on the wordings of these things. So it's increased by about $130 per year per child, or vice versa. Per child per year works also. On average, from 2000 to 2010.
And so long as you have all the stuff in, you can word it a little bit different, right?
Exactly. I'm going to take this one a step farther than was actually asked. And the question we were asked about, we were asked to make a couple of statements about it. And then we were asked to graph the two of them using years after 2000. So that's pretty straightforward. We have 2 points to graph there. And so I'm not going to bother going over that at the moment. But since they're having us graph lines, we should be able to find the equations for those lines. So I'm just going to remind you how to do an equation for a line given information like this. So I'm just going to recopy this to a new page because I am totally out of room. So I'm going to take the work we just did and find an equation that would graph government funding and would graph after-school programs, assuming that linear change. So I'm just going to add a column here for the slope, the rate of change that we calculated, right? And for each of these, we calculated a slope. For government funding, we found the slope, the average rate of change was negative 120. And for the cost of after-school programs, we found that was positive 130. Right? So I can put a plus there. When I find an equation for a line, we often use something that looks like y equals m times x plus b. And usually if x is a time, we use a t for the time. And then for variables, instead of y here, I'm going to use g for government funding and c for the cost of after-school programs. So for the government funding one, I could say, well, all right, g is my y. I've got my slope, that's negative 120 times t. Now I have to write down what t means in a minute. Here I'm just saying g is government funding. And then plus, I'm going to use the 2000 amount for the starting point. And if I choose 2000 to be a starting point, that also tells me what time should be measured in. And so if I made that decision there, now I'm basically saying t is years after 2000. So that makes the equation pretty easy to come up with. Similar for the cost, let's do that in red. That would be positive 130 is the rate of change, the slope, times the time, plus, again, we'll start in 2000, so that would be 3,800. And again, that's still the same t years after 2000. And so the equations are pretty convenient when we choose a convenient starting year. The hardest part was finding the slope for those two. So now I'm going to take those and graph them. So this one starts at 3,000 and drops by 120 per year. This one starts at 3,800 and rises by $130 per year. So for the government funding, and let me zoom in on this a little bit.
What was that? T equals years after 2000?
Yes.
Thank you.
Yeah. So for example, 2010 is 10 years later. And so if into our, say, our government equation, we plugged in t equals 10, that would give us negative 1,200 plus 3,000, or 3,000 minus 1,200, which is 1,800, which is the number, right, we were given there. So my formula checks out okay.
And that graph looks like a triangle. I got it wrong the first time because I only made one line.
Yeah, and here we were asked to show the linear models for the two sets of data. So the government one started at 3,000, and then it went up. So let's see, that goes up 500 there. We're only going up by about 120 every year. So it kind of looks like that right there. But I know that 10 years later, so here's 10 down here, it goes down. Oh wait, I'm doing the wrong one.
3 is the down one.
Yeah. Oh yeah, 3,000 is the one that goes down. Yeah, that's the one I want. Okay.
Don't scare me.
Starting at 3,000, we want to get to 1,800. Trying not to scare you. And then, so there's 10, 500, 1,000, 1,500, and it looks like this is jumping by about 100 at a time. So that's 2,000, 1,900, 1800 should be about right there.
Good, that's just where mine is.
And we can always move them if we think we misplaced them by clicking back on it and moving it. So 15, 16, 17, 18. That's what I thought it was before. And then the other one, double check the numbers. I want to go from 3,800 to 5,100. So 35, 6, 7, 8 is probably about there. And then 10 years later, make sure I'm on the right vertical line. I want to be at 51, which I think is right there. If I have any doubt, I can always pick them up. So 4,000, 39, 38.
Yep, that's how mine looks, like a
So you can
triangle.
see they're heading apart there. And so those are the graphs of the two lines that we made equations for right here. And I don't think I've showed you guys this before, but Desmos has a graphing calculator that's kind of cool. So I'm just going to demo that for fun here, because you might be able to use this in your next math class. We didn't have much use for it. So in Desmos, I would enter it as y equals. So negative 120x plus 3,000 was one of them. And I'm going to have to adjust the scale here. And then y equals 130x plus 3,800 was the other one. And then all I have to do is adjust these to match what they showed over here. Oops, over here. So I want to go from like -1 up to 15 and 0 to 6,000. And so there's a little button here where I can set that. So I'm going to go from -1 to 15. And we could do this on a spreadsheet too. I think here I'll just go from maybe 0 to 6,000. And I should get a picture that looks pretty similar to the one that we found, where the two graphs are heading apart. So that's kind of fun.
How do you get to that in Desmos?
Yeah, so if you just search for Desmos.
Well, I have Desmos like I just click it on my laptop and it goes directly to it.
Yeah, to that scientific calculator, right?
Right.
Yeah, so if you just search for the word Desmos instead, then up should pop a website called desmos.com, and it turns out they have a whole bunch of other stuff there that you can do. So they have a graphing calculator here, which is the one I was just showing. And then over here, they have the scientific calculator. They have a simpler calculator for elementary school kids. They got a calculator for like engineering type students here. They have geometry. Yeah, they got a bunch of other stuff that's useful. So depending on which class I'm teaching, I might use one of their other calculators here.
Yeah, I never knew it had a graphing calculator.
Yeah, Desmos is they're an awesome company. All right, so I think